We have designed loads of platforming levels for our game Halve, and in this video, I want to share with you what kind of obstacles we have encountered, how we managed to solve different issues, and what kind of systems we developed to improve our workflow. Hey, if you're new here, I'm Midas, and together with the team at Moonleaf Studio, we work on our passion project, a puzzle platformer Halve. It's a narrative-driven game where you have to control two characters at the same time by using the same movement keys, in order to beat platforming levels, solve puzzles, and discover the mysterious story about the two lost spirits. Since the gameplay consists of two playable characters that the player has to control simultaneously, you have to keep on constantly thinking about two sides while designing a level, which are the top and the bottom. In some cases, this actually feels more like designing two levels at once, rather than a single level, which was quite challenging to get accustomed to, especially once we just started developing the project. Then both level sides, the top and the bottom, has to make sense movement-wise. You can't really make extremely opposite level layouts in order to make the gameplay fun and, well, levels possible to beat in the first place. Although the biggest challenge of them all is that you have to keep on constantly thinking about the synchronization of the characters. If there are loads of misalignments, the player might accidentally put himself into quite a hectic situations, and the whole level might become a bit too confusing to play. Of course, later on in the game, this kinda becomes unavoidable, especially when player acquires abilities that impact the character's movement. But by then, the player should be quite accustomed to the controls and how to properly synchronize or desynchronize the characters. There are a few different approaches as to how we can design levels in Halve. The most simplistic one and probably the most common one that I use is simply creating a level layout on one side of the level, which is, let's say, at the top, and then copying everything to the other side, in this case to the bottom. Of course, this is quite a simple way of doing things, and it might be a little bit boring if all the game was simply mirrored, and that's why there are some more complex approaches that we use to provide a lot bigger variety of levels. And sometimes those differences can be, well, quite minor, by simply having some obstacles in different positions on both of the sides, and in other cases, well, it can become quite complex when you create different layouts on both sides of the level, but of course they still should have a little bit of similarities in between them. And the last one and the most challenging approach is to create level layouts that are different at the top and at the bottom, and having the player use abilities for each of the characters that impact their movement. For example, the deer character will be able to freeze himself in certain positions on the map, which allows the bird to move freely and do some other stuff. And by combining stuff like this, well, as you can probably imagine, we can do loads of different layouts on both sides of the screen. So how do we design these levels in the first place? Well, before designing any new level, we need to know what kind of mechanics and features should be present in that level. And to plan everything level design related, we use Google Sheet tables. For starters, I create an overall table that contains all, or at least the main mechanics that are implemented in the game. In this table, I mark in which chapter the player will encounter a new feature accordingly, which is very helpful when you need to figure out the progression curve as to when some stuff could be introduced. Then I use this systematic approach, where I write down all of the game mechanics into columns, on the left side and at the top. Then combine two mechanics each at a time, and try to imagine or do some prototypes between those in order to figure out if there are some great correlations. For example, let's take a portal mechanic and combine it with icy ground. I place both of these mechanics in the scene and simply start playing around for a bit to see if I can get something fun out of that combination, such as sliding quickly on ice, jumping into the portal, and flying way further than you normally would. I learned about his system and other neat tricks for puzzle designs from a Puzzle Game Magic Secrets GDC talk. If you would like to check it out, I will leave the link in the description. After figuring out the correlations between different gameplay mechanics and features, I create a few more tables for each chapter, in which I write down what mechanic will be introduced in what level, just so that I have a clearer picture of how the whole progression could be like. And finally, right before getting into Unity to create the levels, I create some tables for each level separately. These tables contain level parts with some subtle descriptions. I mainly state here what mechanics could be included in each part so that I can at least somewhat imagine the progression curve before spending the time building the actual levels, as it is way less time consuming to do some text adjustments rather than to basically scrap huge levels altogether. For example, if we look at the second level's part 2, I have written down two elements here: static danger sources and asymmetrical dangers. And if we look into Unity, I did exactly that. There are asymmetrical danger sources placed at the top and at the bottom. The main idea is just to avoid overcrowding the player with too many new mechanics and too many difficult obstacles all at once. You usually have to take it slow so that the player has some time to get accustomed to everything before tackling a more difficult challenge. And I actually noticed during different playtesting sessions that we did with our game that this approach works really well, as the players get hooked on the game, and as they're usually not getting stuck at a single part of the level for too long, the gameplay feels fresh for them and they just want to keep on playing and having fun. In Unity, I have created a bunch of rectangle block variants, or rather prefabs, that are used to create the levels. This way I don't need to create new blocks every time I create a new level section, and I can just simply snap the blocks one to another to create a large variety of level layouts. Most commonly, my first step in creating a new level section is to place the blocks next to each other. Then comes the other side of the level, the bottom. To be honest, I did all the copying by hand before, by simply selecting all the blocks that I wanted to and duplicating them to the other side. And as you can probably imagine, it can become quite time consuming, especially if you have a huge section of the level. And this is the main reason why we ended up creating a tool that allows us to duplicate selected objects to the other side of the level by simply doing a few clicks. Of course, if I want to make the sides at least slightly different from one another, I still need to do some adjustments by hands and drag some blocks in opposite directions, but it's still great to have a starting point that I can actually start working from rather than creating everything from scratch. Then I playtest to see if jumping, spaces and other gameplay aspects are correct and feel exactly as I want them to. Of course, this is an iterative process and I keep on constantly moving between the playtesting step and the block placement step until I'm satisfied with the result. Once the ground blocks are set in place, I start placing and configuring all the obstacles and other interactive elements such as gates, runes and these shrinking plants. And of course, once the interactive elements are properly set up, I start to do some more playtesting. When the level part is finished, I start working on proper camera follow settings, and for that we are placing trigger boxes in specific areas. If a player collides with that trigger box, a new Cinemachine camera with proper settings is enabled. In this case, the camera's distance is set to be further away than the default camera. This way, when the cameras are switched, the character should be always visible. If you're wondering how we do these transitions between different cameras so smoothly, well, it's actually quite simple to do if you are using Unity's Cinemachine package. Under the Cinemachine Brain component, there is a blending option that dictates what the transition between new cameras will be. Ease in out option creates the smooth motion that you see here. And once everything is finished, it's time to do some more playtesting. Because every time when I do any sort of adjustments, including simply moving the camera, it's actually really important to playtest and see how everything looks from the gameplay perspective as much as possible. Because even the slightest changes, such as providing a bigger distance to the camera, could impact the whole feeling and the gameplay aspects quite a lot. And after the blockouts are all placed and finished, and the gameplay feels fluid, we move on to the next step, which is to set dress and decorate everything. But I'm not gonna share the decoration process in this video because this is most likely a topic for a whole video. So make sure to hit that subscribe and notification bell so that you don't miss when that new video comes out if you would like to see how we decorate everything. And so, what are my biggest takeaways from all the experience that I've gathered while designing a bunch of levels for like over a year or so? Well, first of all, you gotta make as many blockout presets and different systems as you can in order to skip as many mundane tasks as possible, so that you get to the finished level design as soon as possible. Even if you only manage to skip a few steps with the tools that you have created, I'm pretty sure it's still worth it, because in the long run it's going to help you save a tremendous amount of time, especially if you have a lot of levels to design. The other takeaway is that you shouldn't be afraid to scrap some of the level parts that you have created or designed, if you think that these parts are not going to work and just don't feel as you wanted them to. Sometimes the ideas that we get for levels sound really cool verbally or written on text format, but if you try them out in practice, they just don't really work that well. I've noticed that the best level design comes from loads and loads of iterations, so make sure to destroy those bad levels and don't get too attached to any of them. And if you can't really decide if the level is the right fit for you, well, just listen to your players, because they know what's best for them. You can easily see from their reactions if the level is good or not. And finally, as with probably most of the gameplay development aspects, you just gotta playtest as often as you can, just so that you get a proper feeling of how the game will play out. In my case, well, I think I probably played through each one of the level that I have designed for over 100 times, until I reach some satisfying results. And of course, the more you play, the bigger the chances are that you will get some really cool creative ideas on how to make some really interesting levels. I really hope that you enjoyed my insights into how we are creating levels for Halve. And as I mentioned before, I didn't really cover any decoration process elements in this video, so that's going to be the next devlog. But on the meanwhile, if you ended up sticking here for so long, I'm sure that you might enjoy my previous devlog, where I cover how we created Halve's character design from start to finish. And as always, thanks for watching, and I hope to see you in the next one. Bye bye!